I have didn't we talk about this last class? A little awkward timing there. Also a little rude, but I got thick skin. I have a video I would like to show you guys. No. Someone shared this with me this weekend, and I thought of you guys, and I thought of our class, and so I wanted to show it to you. For that, among other reasons, I would just ask that we step it up a little bit. I'll give you your planner first. I'm sorry. I got ahead of myself. Sorry. Oh, did he take that paper?
I don't know.
Not you. Shh. Whoa. Not talking all at once. Hey, sorry. Monday. I'm sorry, I forgot. It's because I had to pee so bad. Excuse me. I said excuse me. I had a lot of candy today.
Yes, I took it as you were telling me to excuse me.
Oh, I see. Shh. Okay. In your planners, please. And go get one. Bye. Then use a piece of paper and write it down because I'm not going to give you time later. You know what? So Monday, today, math. Tomorrow, build. Wednesday, Veterans Day. No school. Think of it. We're also going to have a build day on Thursday. So the homework for today is due on Friday. Also, it doesn't say it on there because I haven't completely decided, but you could very well be taking a quiz on Friday. Just throwing it out there. On what? On the stuff we've been doing on slope, Pythagorean theorem, a little bit simplifying radicals. Just making sure you are prepared. Don't know yet, but maybe. Okay? Awesome. So, that's the schedule for the week. You do need to pay attention the whole time. It is in Spanish, so there are subtitles. I don't think that should affect. It's only 9 minutes long, so I'm asking for 9 minutes of concentration. We better move that notebook real quick. What's he doing over there? Better not be coughing. Oh, it's a planner. Forgive me. Whew. Okay. So please pay attention. What are you doing, kid? Oh. Yes, it is. You can watch this TED Talk. I didn't write it. What I would like you to do, without talking. Can't tell your other one. Okay. As your warm-up, I would like you to use complete sentences to answer these 3 questions. You are going to be sharing your answers, just so you know. So it's not an option to sit and do nothing. Matthew, put your head up, please. Okay? So first question, what is something that you learned from the video? Second Second question, what theorems do you know? Third question, why do you think I showed this to you? I would like you to answer these individually. It means you are not talking. It does not take someone else to tell you what you think. What do you think? As you write, please have 17 through 25 out so I can quickly check them all. So, Mitchell, do not play with the rulers. Who can tell me something you learned from the video? Roll. What's the honeycomb theorem? So the honeycomb theorem, something you learned maybe, was that if you had any two-dimensional shape, piece of paper, the best shape to cover that paper with no gaps, and the best shape is the one with the least perimeter, would be a honeycomb, hexagon, honeycomb. It is not the best shape because bees use it, right? It has been proven to be the best shape, but it is probably, because it's the best shape, it's probably one of those wonderfully beautiful things about, like, that's why bees use a hexagon, because it is the best shape.
Because evolution.
Circles leave gaps, dude. Hoots.
Did you just say poops?
Okay, something else you learned. Shh, dude.
Sorry.
I was gonna say that a sphere or a circle can be used to fill up space, like in a three-dimensional setting that would be a sphere, but because they leave gaps, you can't fill them.
Right. You can't fill, it's not the best shape to fill a space with because you don't fill all of it when you use circle or sphere. What else? Luis. Yeah, you gotta prove it though. If you're gonna love someone forever and ever, you should give them a theorem.
Prove it.
And a proven theorem. You clearly didn't pay attention. You're saying what? What else? Awesome.
I learned that it's forever able to prove it, like a theorem, and it's true until someone proves it.
So there's a conjecture and then there's a theorem. So generally, right, there has been a theorem, there's no such thing as disproving a theorem. Because a theorem is something that has already been proven. It's agreed upon. What can happen sometimes, though, I will say, is there can be an error in the proof. Every once in a while that will happen. There's a great unsolved problem. Oh, I'm not going to tell you. Never mind. That has no proof, but it's really cool. I'll tell you later. I was going to get off task because I get too nerdy, but no. What theorems do we know? What? The honeycomb theorem, you learned that one. What else? Finn. The Pythagorean theorem.
He seems so happy.
Woo! We're going to use the Pythagorean theorem to talk about it. It's the reason, like he said, the Pythagorean theorem would be true even if the world didn't exist anymore. Whenever there's a right triangle, the Pythagorean theorem is going to be true. There are few things that we can be so sure about. Okay, when you're talking about number 25 on your homework, those are only right triangles on number 25 if and only if their sides and the hypotenuse fit the Pythagorean theorem. They have to. Otherwise, they're not right triangles. The Pythagorean theorem is always true. You can't have some right triangle and be like, nah, the Pythagorean theorem just doesn't work for this one. It works for every single right triangle, always. Always, always. If your side lengths and hypotenuse don't fit, you don't say, oh, Pythagorean theorem's kind of weak. No, your triangle is not a right triangle. Okay? Yeah, Mickey.
What's the theorem that says that all angles in a triangle?
The triangle sum theorem. All angles in a triangle add up to 180. Always true. Always true. Any triangle, if you take all three of its angles and add them up, 180 degrees. Always. Prove it. Okay. Why do you think I showed this to you?
Because math.
Levi. Yeah, I told you that. That's not what what do you think I showed it to you? What else? Major. You're about to learn about it, for sure. What else? Do.
So in the beginning, we were talking about how math is applied to like outside of studying it for hours in school, and that's kind of what we're doing here is you use it instead.
Yeah, I really hope so. He kind of talks about a little bit about how some people get defensive about math. Well, it's in everything. I'm not gonna. It is, but I'm not gonna lie to you. But the hope of this class, pick your heads up off the desk. 1, 2, 3, 4. Thanks. The hope of this class is maybe that you don't go. Maybe you don't go on to think that it's like the end all be all like I do, but that you at least realize your experience with the math was a bit more meaningful than it could have been otherwise. That's all I gotta say about it. Okay. We'll go 1, 2, 3, and then we'll be done. Mariah. Oh, I don't think I need to answer that anymore. Finn.
About the why did we do this?
Uh-huh.
I said because through our work, to prove that if you want to get it, say like a theorem, if the proof some behind the thing that actually makes it prove. Okay,
I might show you guys this again next semester when you start proofs. You guys are going to be proving some stuff. You'll find out. But yeah, we're going to be proving stuff. That'd be nice.
What you're not gonna do?
I hope so. Maybe some of you. Sure. Nope.
She's already done plenty to
Um,
do that.
Next up, speaking of homework, great transition. Thank you, Matthew. You guys are going to have, we're going to take 5 minutes to talk about our homework. Now, here's the deal. I do not want to hear a conversation around anything else. You need to have your books open. You need to be talking about 17 through 25. Hold on, please. Where's your book? Then you're not going to be in here for this. You can go and wait in the hall. Okay, then go. You guys can go wait in the hallway. We'll get you when we're done. You don't come to class unprepared. I didn't forget about you last time. If you guys think it's so funny, you can join. 17 through 25. Each and every question. If you are someone who faked it on your homework, I certainly know that those of you who did. Okay? It is extra your responsibility to learn something right now. If you haven't figured it out from quarter grades, you can't fake it in this class. If you don't know what you're talking about, you're going to have an F. This class is not middle school. You can't just show up and put on a smiley face and fake your homework and get an A. And I've had a lot of conversations with parents this past week about but they've always had straight A's. Ooh. I'm like, well, I don't know what to tell you. They're not doing their thing in here. Okay, this is not like you're nice and funny, so I give you an A. This is the grade that you earned. You have to know something. And also, spoiler alert, the rest of your math classes here at Benson are all going to be the same way. Okay? You are responsible for this material. I do not want to hear, I'm going to say this nicely to start with. I do not want to hear any other conversation except for math conversation. I'll say that nicely. If you'd like to find out what it looks like when I say that meanly, you can test it individually. Okay, 5 minutes. Ready, set, go. Sorry, I'm not answering your question. At the very least, I would highly recommend you are putting down the correct answers. Okay, 17 should have been a 2-inch by 3/4 inch box. You could have used an architect scale, or you could have done some math and used a ruler. Okay? 18, yes. 19, 15.52. 20, 10,160.02. 21, B, then C. 22, 1397.73 feet. 23, 33.94 feet. What, Levi?
For 90 goes around to the nearest 10 around to the 100.
Cool. I don't think he's asking why I did that. I think he knows the correct answer and just wants to point it out. Looking for problem areas. Yeah. Huh. Okay.
I was talking.
Hold up. I know, but just for 18. So 18. Yeah. 18. Anything else? Or you can also second problems. 20? Yeah, Ian. Oh, Ian's shirt reminded me. I'm going to tell you one more thing. I'm going to tell you one thing. Two things, actually, I'm going to tell you for real. I'm going to tell you that if you didn't know, the Timbers won their playoff game last night against Dallas. So, against Vancouver. Hey, yeah, it's cool. Let's hit on the Timbers because I don't do anything with my life. Cool. Second of all, they don't play again until the 22nd. We'll talk then. What? Yeah, and they're playing FC Dallas. I didn't see her. Okay, second, more cool, I think cooler, is that little known fact. Does anyone know that a Portland team won a world championship yesterday?
What?
Yeah, little known
Something
fact.
wonderful like Portland.
It is it's pretty Portland. The Rose City Rollers are Portland's roller derby team. They won a world championship yesterday, last night, which is kind of cool. I don't know. I didn't even really know it was a thing, but yeah. So
I didn't know we were back up.
hey, little Portland pride. Little Portland pride. Okay, now that we got that out of the way, I'm gonna talk. For 5 minutes max. I'm going to remind you, if you don't want to pay attention, then just shut up. Okay? Love you. Also, well, that's a stupid choice, but I'm not going to go into that choice with you right now because I'm done talking to you. Pretty easy. Pretty quickly. The slope of 6 over 11 has a rise of 6. A rise of 6. You can kind of see it here. I'll draw one in. A rise of 6, a run of 11, or tread of 11. Rise over run, 6 over 11 is 0.54. If I compare this number to this number, which one is smaller? Think about dollars and cents. Which one is less money?
0.5.
This is smaller, so look. If it's smaller, it is less steep. This code requirement is saying it cannot be steeper than that. It could be less steep. It can be no steeper, right? You don't want some crazy high stairs. Okay? That would be pretty brutal. Alright? Let's talk about 20. I saw someone do this on their paper on 20 and I thought it was great. Yeah, blah, blah, blah. Bunch of stuff. Doesn't really help you that much. Okay? A lot of you Is that you doing it, so? Stop making a noise. That's Max, right? A lot of you like came in and said like the words. Just we need to learn how to scan through problems. Okay, yeah, there's a bunch of blah 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 at the front. Okay, the main part of the problem is down here at the bottom. Okay, one of the things you need to do, and you can see it like that's my work. This is me figuring out. Here's what I'm doing. Okay, here it tells you, and I'm going to rework this for us because a lot of us have questions on 20. I think slope is mixing us up. We said from east to west, the road has a run of 8,941 feet. The question about this is what's the rise? Okay. This is the rise. This is the run. Rise, run. It tells you that the grade is 0.895%. Now that's fine and dandy and all, except we don't usually work in percents. Okay? I need this to be in a decimal. Percent to decimal. Percent is a ratio. What do? No! Going backwards. I'm not multiplying. Dividing by 100. Okay? Percent back to decimal. I'm going to divide by 100. Okay? Wait, did I lie to you? No, I need it to go this way. So that's dividing, right?
Yeah.
Okay, it is. Yeah, it's a really small number because here, yes, this is correct. If I was making this a percent, I'd be multiplying by 100, which would be that as a percent. Okay, it works. Okay, so it tells you your rise over your run needs to be this. Your rise over your run needs to be that. Your rise over your run is 8,000, needs to be this really small decimal. Okay, if my question is what number, Chris, don't talk to Julia, what number divided by 8,000 gives me small decimal? I need to work backwards then, right? What's the opposite of dividing? Timesing. So I need to do my rise is going to be this decimal times 8,941. And when I multiply those out, I get my rise is 80.02 feet. So the rise here is 80 feet. So it takes 8,000, travels 8,940 feet, only rises 80 feet. The question though wasn't about the rise, the question was about the elevation, and it said here, you start at 10,080 feet, 10,080 feet, and if we rise another 80.02 feet, right, your final elevation then is going to be 10,160.02 feet. Okay. A lot of layers on that one. A lot of layers. Real quickly on 22. Again, it kind of has a lot of blah, blah, blah. What did I do? Oh, okay. What's the question again? How long is the ramp? Okay, let's see if I can do it. I'm confused right now. I know, but I'm confused about what I did. Okay. Tells you that this is 445 feet long. Okay. That's useful information. It's talking about the capstone, the top thing, the very top stone. Let's pretend it looks like that. The very top stone is 3 feet high. So to get a ramp up there, right, the ramp I'm going to draw needs to go to that 3 foot mark. So what's the height of the ramp? It's not 445 feet. 442 feet. Okay? That's the ramp height. Then it tells me rise to run is a 1 to 3 ratio. It says it's a 1 to 3 ratio. The rise to the run. 1 to 3. So if the rise is 1, the run is going to be 3 times bigger. Hey, chatties, zip. If the rise is 1, run is going to be 3 times bigger. So if we know our rise, how do I figure out my run? Say louder. Multiply it by 3. Multiply it by 3. I get 1,326 feet. And if the question was how long should the ramp be, you now have a right triangle where this is C. So you would do 442 squared plus 1,326 squared is equal to C squared. And then you do some Pythagorean theorem magic, square them, add them, square root, to get your answer of 1,397.73 feet. Okay. All right. Okay. Yeah. You guys are having, you have a task? A task. I accidentally said quiz last class and I got all crazy. So let's just call it a task. It's going to be a graded task. Okay. It's graded. That sounds worse than I'll call it a quiz. I will say you are working individually. As a reminder, individual work means you're not talking to the people around you. You're working on your own, having your own thoughts, showing your own work. Questions? No. I'll hand this out when you're quiet.
How many points did you have?
Is the prime factor route, where I take the square root of 24 and I break it up into multiples of 24, like maybe I say, I went 6 and 4, sorry. 6 times 4, 2 times 3, oh, I shouldn't have done 6 and 4, but I did. 2 times 2. This is what we were working on last week. Break it down into the prime factors. As a reminder, any pairs, right? So of our factors, the prime factors of 24, there's a 2, a 3, a 2, and a 2. Okay? The pairs get to be represented on the outside of the square root as a 2. The 2 times 3 is still left inside of the square root because they don't get to go to the dance. And then I would write my answer as 2 times the square root of 6. Okay? That's option 1. Now, chatting, zip. You would need to stop talking. Right up your head up, please. Okay, we're going to start talking about, there is another way to do this. Some of you may feel like this is arbitrary. The other way to do it also has a little bit of arbitrariness to it, but I'm just giving you the option. So there are multiple ways for, we all think a little bit differently. Okay? I'm going to call this the perfect squares option. Because really, here's what we're trying to do. We're trying to break this up into perfect squares. Things that have square roots. What's a number that has a square root? 16, because why? Okay, 16, because 4 times 4 is 16. What's another number that has a square root? 4, 9, don't say 5. 81, 64. Okay, so again, yes. No, not 11 or 21. Don't say 21. gonna stay late if you don't have this written down, aren't we? That'd be fun. Fun times.
Yeah, it's just laying back.
I'm not kidding. We don't even hear the bells, so I don't mind. I just pretend like I didn't know. Oh, cool. If the clock dismissed you, do I? If you'd like to challenge it, Major, you can keep talking. We can talk about that a little bit for a while, and then the bell can ring, and then we'll go and finish our notes. Would you like me to keep addressing what you said, Major? Cool. Me too. We're going to try to break this into square factors. Those are the numbers 4, 9, 16, 25, etc. If I can break my numbers up into a square factor, a square number, then I could take the square root. So, for option 2, this would look like this. I would write the square root of 24. Thinking about square factors, I know it's divisible by 4. 4 times 6 is the same thing as the square root of 24. Now here's where the arbitrariness of our option 2 kicks in. Also somewhat arbitrary in that you guys don't really know yet that the square root of 4 times the square root of 6, I can write separately. I can break up that square root. I'm not telling you why, right? That's kind of an arbitrary step. But it is mathematically allowed, I promise. And here, then I would say, okay, awesome, the reason for doing that now, what's the square root of 4? 2, and my answer would be 2 times the square root of 6. Okay. So, you might prefer the first method, you might prefer the second method. Don't leave yet. What? Thanks. I would like you, right now, and if you're talking and packing up, you're not going to go. We still got 2 minutes. Simplify that, trying to do it 2 ways. At least right now, I'm trying to do 1 way. Choose a method right now to simplify the square root of 96. The square root of 96. In fact, try and do it this second way, because we haven't done it yet. Try and do it this second way. Find the biggest square number it's divisible by. Find the biggest square it's divisible by. Hint, don't choose 4. Find a bigger square number that 96 is divisible by. I would like you to try this way. Just do 96 divided by 1. What's 96 divisible by? 16 and what? Look, check it out. I can write this, but 8 and 12 are not squares. 16 is a square number. That's why I'm choosing 16, because it's a square number. Because here, I can rewrite this. I can break apart my square root, and then look, what's the square root of 16? 4. So the square root of 96 simplifies down to 4 root 6. That's all you got to do. We are going to practice option 2 and 1 tomorrow, just so you know. We're going to do a little bit of math when we start. Pack up. Pack it this way. Bye. Yes, you may.